Dear students, Assalamu alaikum. Hope you are fine. It's our lecture number 8 and unit number 2, Real and Complex Numbers. Subject Mathematics of class 9th. Dear students, before to start exercise 2.1, two definitions are very important. Number 1, rational numbers, and number 2, irrational numbers. First, rational numbers. All numbers of the form p over q, where p and q are integers and q is not zero, are called rational numbers. The set of rational numbers is denoted by q. That is, q is equal to p over q, such that p and q belongs to z, that is set of integers, and q is not equal to 0. For example, the numbers 1 by 7 and 9 by 2 are rational numbers because their numerator and denominator are integers. 9.25 is also a rational number because its decimal representation is finite, and in the last, the number 0.666 so on is also a rational number because its decimal representation is non-terminating, that is has no end, and is repeating. Number 2. Irrational numbers. The numbers which cannot be expressed as quotient of integers are called irrational numbers. The set of irrational numbers is denoted by q dash, that is q dash is equal to x such that x is not equal to p over q, where p and q belongs to z, that is set of integers, and q is not equal to 0. For example, the numbers under root 2, under root 3 and under root 5 are irrational numbers because these numbers have square root and are not perfect square. And pi and e are also irrational numbers because their decimal representation is non-terminating, that is has no end, and the decimal representation is not repeating. Dear students, it's time to start exercise 2.1. Question number 1 is, identify which of the following are rational and irrational numbers. Its solution is part 1. Under root 3 is an irrational number because the number under the square root is not a perfect square. Part 2. 1 by 6 is a rational number because in this fraction both numerator and denominator are integers. Part 3. Pi is an irrational number because decimal representation of pi is non-terminating, that is has no end, and the numbers in the decimal representation are not repeating. Part 4. 15 by 2 is again a rational number because both numerator and denominator are integers. Part 5. 7.25 is a rational number because its decimal representation is finite. Part 6. Under root 29 is an irrational number because the number under the square root is 29 and is not a perfect square. Dear students, now we start question number 2. Convert the following fractions into decimal fractions. Its solution is part 1. Dear students, you can solve this question by using your calculator and find 17 divided 25, that is equal to 0.68, and in part 2 19 divided 4 is equal to 4.75, and in part 6 25 divided 38 is equal to 0.65789. Solve remaining parts yourself. Question number 3. Which of the following statements are true and which are false? Its solution is part 1. 2 by 3 is an irrational number. False, because 2 by 3 is a rational number. Part 2. Pi is an irrational number. It's true. Part 3. 1 by 9, that is equal to 0.111 so on, is a terminating fraction. It's false because it's non-terminating fraction. Part 4. 3 by 4 is equal to 0.75 is a terminating fraction, it's true, because in decimal representation the numbers are finite. Part 5. 4 by 5 is equal to 0.8 is a recurring fraction, it's false, because in decimal representation there is only one number, that is 8. Question number 4. Represent the following numbers on the number line. Its solution is part 1, 2 by 3. Dear students, because numerator of this number is less than denominator, so it is a proper fraction, and a proper fraction is always less than 1. To show this number on the number line, we can see that its denominator is 3. So we will divide the area between 0 and 1 into 3 equal parts, and because its denominator is 2, so we can count 2 lines from 0, and arrow shows the place of this number 2 by 3. Part 2, minus 4 by 5. Dear students, this number is again a proper fraction because its numerator is less than denominator. The solution is to show this number on the number line. Because this number is negative, so this number will be on the left hand side of 0, because denominator of this number is 5, so we will divide the area between 0 and minus 1 in 5 equal parts, and because its numerator is 4, so we can count 4 lines from 0, and the arrow shows the position of the number minus 4 by part 3, 1 whole number 3 by 4, which is equal to 1 plus 3 by 4 and is equal to 1.75. Dear students, its solution is to show this number on the number line. We can see that because this number is greater than 1 and less than 2, so this number will be in between 1 and 2. Because in fractional part, the denominator is 4, so we can divide the area between 1 and 2 in 4 equal parts, and because the numerator is 3, so we can count the lines from 1, and the arrow shows the place of the number 1 whole number 3 by 4. Part 4, minus 2 whole number 5 by 8. Dear students, we can write this number as minus as common and 2 whole number 5 by 8 as 2 plus 5 by 8, that is equal to minus 2.625. The solution is to show this number on the number line. We can see that this number is less than minus 2 and greater than minus 3. So this number will be in between minus 2 and minus 3. Dear students, you can see that the fraction part of this number is 5 by 8, where 8 is the denominator. So we can divide the area between minus 2 and minus 3 in 8 equal parts. And because its numerator is 5, so count 5 lines from minus 2, and arrow shows the place of the number minus 2 whole number 5 by 8. Part 6, under root 5. We know that 5 is equal to 4 plus 1, and 4 is the square of 2, and 1 is the square of 1. So we have converted 5 into sum of squares of two numbers. The solution is, the students, to show this number under root 5 on the number line, we can draw a right angle triangle OAB. Let AB is equal to 1 unit and OA is equal to 2 units. Then by Pythagoras theorem, OB is equal to sum of squares of perpendicular and base. Because its base is 2, so we have 2 square, and because here perpendicular is 1, so we have 1 square, that is 4 plus 1, which is equal to under root 5. Now we have OB is equal to under root 5. So by drawing an arc with center at O and radius OB is equal to under root 5, we get point P representing under root 5 on the number line. Question number 5. Give a rational number between 3 by 4 and 5 by 9. Its solution is, dear students, required rational number is the half of the sum of 3 by 4 and 5 by 9. by taking its LCM, and after solving we have 47 by 72 is the answer. Question number 6. Express the following recurring decimals as the rational number p over q, where p and q are integers and q is not equal to 0. Part 1. 0.5 bar. Its solution is, let x is equal to 0.5 bar. Dear students, here bar mean non-terminating reckoning number. So we have x is equal to 0.555 so on as equation number 1, multiplying both sides by 10. We have 10x is equal to 10 multiplied by this number. Dear students, if we have a single number under the bar, then we will multiply by 10, and if we have two numbers under the bar, then we will multiply by 100. So 10x is equal to 5.55 so on as equation number 2. Subtracting equation 1 from equation number 2, we have 10x minus x is equal to 5. So 9x is equal to 5 and x is equal to 5 by 9 is the answer. Part 3. 0 point bar of 6 and 7. Its solution is, let x is equal to 0 point bar of 6 and 7, because under the bar there are two numbers 6 and 7. So x is equal to 0.676767 so on as equation number 1, multiplying both sides by 100, and we have 100x is equal to 100 multiplied by this number. The students, because we have two numbers under the bar, so we will multiply by 100. And 100x is equal to 67.6767 and so on as equation number 2. Subtracting equation number 1 from equation number 2, we have 100x minus x is equal to 67. So 99x is equal to 67 and x is equal to 67 over 99 is the answer.